Okay, in today's very short lesson, we're only going to do 2 examples, and we're going to be factoring quadratics in order to find the solution. Now, in previous lessons, we've talked about how solutions is just one of many words we can use. We often use roots, solutions, zeros, and x-intercepts. Those are all interchangeable. You can use any one of them at any given time. They all mean the same thing. So let's look at this first example. The first step to finding roots of a quadratic equation or function is to factor the quadratic out. And what we mean by factor the quadratic is we mean to take this and set it into 2 equal binomials or 2 sets of parentheses. Because it's a positive positive, you're going to have a positive positive in your binomials. Now it's like a puzzle. You're going to have to ask yourself, what numbers multiply to give you the last number, but add to give you the middle? And the way I like to do this is I kind of make a little t-chart, and it helps when you have really big numbers for the last one. And what 2 numbers multiply to give you 2? Well, 1 times 2 gives you 2. And if I was to add those, I would get 3. And that's exactly what I'm trying to do. So inside my parentheses, I have a 1 and a 2. So now that's factored out. Now we move on to the next step. Once the quadratic equation is factored, the next step is to find the actual answer, your roots. Now your roots are found when y is equal to 0. Therefore we must set the 2 binomials equal to 0. So we had a 1 and we had a 2. Now this allows us to find x when y is 0, also known as our x-intercepts. So if I want to get rid of that 1, meaning I want x by itself here, all I need to do is subtract 1. But the rule in algebra is what you do to one side of the equal sign, you have to do to the other. So 1 minus 1, that goes away, which leaves us with the x. And 0 minus 1, well, that's just negative 1. Here, we have x plus 2 equals 0. Remember, we want x by itself. So I'm going to subtract 2 here and subtract 2 there. That cancels out, which is exactly what I wanted to happen. So 0 minus 2, well, that's just negative 2. Now, when we write these roots, we can also write it as an ordered pair. There's nothing wrong with leaving it like this. But we can also write it as an ordered pair. And all we do is we just take these numbers that we got here and write them. Now remember, we're talking about an x-intercept. So your y will always be 0. Let's look at one more equation real quick. Now we have a minus minus. Because it's a minus minus, we're going to have a minus and a plus in our binomials. And the bigger number has to go with the negative. Think of it as a double negative. If you have a negative number and you're going to combine it with another negative number, you're going to get a really, really big negative number. So the big number, double negatives, it's bigger. That goes with the minus. The other one is going to be the positive number. So just like we did up here, we're going to take our C value, the last number, and we're going to make a list of all the numbers that multiplied to 84. Okay, ready? So, we're going to start. I'm going to scoot this paper over a little quick. There we go. 84, we have 1, and negative 84. Remember, the bigger number has to be the minus. Now, let's look at another one. So, after 1 comes 2. So, 2 and what number will work? If you're not sure, you can always just get a calculator and divide by 2. If you did that, you should get a negative 42. Or a positive 42, and just make it negative. After that, you try 3. And 3 gives you a positive 28. So, there we go. And then if you were to try 4, you would get a positive, you'd get a positive 21. Make it into a negative. If you were to try 5, that shouldn't work. And what I mean by not working, I mean that you're going to get a decimal, and that's something that we don't want to mess with. You want perfect, pretty, even numbers. So, when I try 6, that should work, and you'll get a, oh, I'm sorry, no, 6 does not work. 6 is a negative 14, and 17 was a negative 12. There we go. 6 did work, I'm sorry. Now remember, these are all the numbers that are going to multiply to give you 84. Now from that list, what we need to do is we need to come up with a number that's going to add up to this negative 5. So let's do that. If you have 1 and you take away, or you add a negative 84 to that, you're going to end up with an 83. And that is something that we do not want. And if you have 2 and you add a negative 42, that's negative 40. Again, that's something that we do not want. We want a number that's going to add up to a negative 5. So if I add 3 and a negative 28, I'll get negative 25. If I add 4 and a negative 21, I'll get negative 17. I'm getting smaller numbers, so that means I'm doing something right. I'm going in the right direction. 6 plus a negative 14, that's negative 8. And this one has to work because it's the very last one. 7 plus a negative 12. And yes, that does give us a negative 5. So, there we go. Those are my two magic numbers that when I multiply, I'll get a negative 84, and when I add them, I'll get a negative 5, which is exactly what I want it to do. So, my big number goes here. In this case, that's the 12, and the 7 stays positive. I already have my 7 there, so I put my 12 here. I'm going to solve for x, just like I did above, okay? And when I do that, I'm just going to add 12 here, add 12 here. So my 12s cancel out, leaving me with x all by itself. 0 plus 12 is a positive 12. Now, looking at just these three answers, do you see a pattern? Well, if it was positive inside the parentheses, we kept that number, we just changed the sign. So a positive 1 becomes a negative 1. A positive 2 becomes a negative 2. A negative 12 becomes a positive 12. And following that pattern, a positive 7 will become a negative 7. If I wanted to write it as an ordered pair, I would write it as 12, comma, negative 7. And that concludes our lesson for today.